In this video I am going to explain about resistors connected in series and resistors connected in parallel. In series connection the resistors are connected in one by one continuously. This diagram is going to be used for the series connection. In parallel connection the resistors are connected in one by one parallel. That means the right side leads are connected together and the left side leads are connected together. This diagram is going to be used for the parallel connection. You can see in this diagram three resistors are connected in series. First resistor is R1, second resistor is R2 and the third resistor is R3. These resistors are connected together with a battery source E1. Let's start it with the voltage rules of series resistors. This is the voltage rules of series resistors. The voltage rules state that the voltage gains from the battery is equal to the sum of voltage drops across each resistors. So here the voltage gain from the battery is Vt. So the voltage Vt is equal to the voltage drop across the first resistor V1 plus voltage drops across the second resistor V2 plus voltage drops across the third resistor V3. Let's going to explain about the current rule in series resistors. For the current rule state that the current out from the battery is equal to the current passing through the each resistors. The current starting from the positive pole of battery is entering in the first resistor R1 and passing through the second resistor R2 and third resistor R3 all the way and entering through the negative pole of the battery. So here the current is passing in a single path. There is no way to going out and entering to this loop. That's why the current in all the resistors are equal. We can say that current IT is equal to current I1, I2 and I3. So here we can derive the formula of total resistance RT is equal to R1 plus R2 plus R3. Because as per the Ohm's law voltage is equal to product of current and resistance. Here the current is same, so the total resistance is equal to the sum of each resistors. So the total resistance in the circuits RT is equal to resistance of first resistor R1 plus resistance of second resistor R2 plus resistance of third resistor R3. Let's see this example of resistor in series combination. Here I am going to explain you how the circuit affects the current and voltage variations while changing the resistance. First you can see the current is equal in each resistors and the voltage source, but the voltage is different in across the each resistors. Now I am going to change the first resistor to 2 kilo ohms. So you can see the variation in the circuit. The current is reduced in circuit because of increasing of resistance. But all the way the current is equal. Let's check the voltage. It's different in each resistors because of voltage dropping in the resistors. Let's check how about the parallel connection works. I'm going to start with voltage rules of resistors in parallel. Here we can see that the voltage is applied in all the resistors together. So the voltage from the battery is affected in each resistor is equal. So the voltage total is equal to the each resistors. That's why Vt equal to V1 plus V2 plus V3. Now going to check about the current rule in parallel combination of resistors. It states that the current delivered from battery is split and passed through the each resistors. That means the current coming from battery is split and passed through the first resistor is I1 and passed through second resistor is I2 and passed through third resistor is I3. So the total current in the circuits IT is equal to sum of the current passing through the each resistors. That means IT is equal to I1 plus I2 plus I3. Total resistance in parallel combination we can derive the formula using Ohm's law. In parallel combination the voltage is equal in each of the resistors. So we use the Ohm's law. Current I is equal to voltage divided by resistance. So the gain current is Vt divided by Rt equal to V1 divided by R1 plus V2 divided by R2 plus V3 divided by R3. Here the voltage is same, so we can write 1 divided by Rt equal to 1 divided by R1 plus 1 divided by R2 plus. Here going to explain the operation of the parallel combination of resistors. You can see the voltage is applied to the circuit. The current is split into equal in all the resistors. Total current is the sum of current passing through each of the resistors. Now I am going to change the first resistor to 2 kilo ohms. Then we can see the current in first resistor is reduced. Also the total resistance is same as before, the sum of current in each resistors. Thanks for watching.